Going live in three.
Hello, everyone, and welcome to the first day of Dev Days. I'm very excited to be your host for today. My name is Karen Kenzie. I'm a senior software engineer and a community leader from Israel. And I'm very excited to welcome our first speaker of the track, Jorge Ortiz. Welcome, Jorge. Jorge
Thank
is
you
a
very much.
mobile developer advocate at MongoDB, as you can see from his background. It started his way back in 1993 as a developer at MIT. And in 2008, he shifted to mobile development and is been working as a mobile developer and architect and share his knowledge ever since. So welcome, Jorge.
Thank you.
I want to remind you all that to be active, ask questions, give your feedback, because the most active participant have a chance to win free ebooks thanks to our partner Pact. So keep that in mind. Enjoy. Have a wonderful day, and let's get started. Good luck, Jorge. I'm sure it
Thank you
will be
very
a very
much.
interesting talk, and see you soon.
Thanks. Okay, so let me start by sharing the slides with you. Give me just a second so I can grab the uh, window where I have the slides. And I hope that you are all watching now the presentation deck that I have for you. So this is going to be, as Karen said, a talk about architecture. It will mostly apply to iOS, but as you will see immediately, it can also be used for other platforms or even environments. So you can perfectly apply these contents to Android development and also to other things like microservices. So if you are not doing iOS development, be my guest, because still I hope this will be interesting for you. The agenda that I have in mind for today is to start by learning a little bit about you, and that means that I will ask you a few questions, and I beg you to answer them. So I grab a little bit about your background, and I can tune the talk to your needs better. Then I will talk about presentation logic, like usually the most ignored logic in our applications. Then we'll talk about use case factories, how to implement them, how to make them asynchronous. And I will then cover connectors, which will be devoted to do proper navigation and dependency injection in iOS. I will finish with a very brief recap, and I will be available for your questions, and I will try to provide my answers. So without further ado, this is a talk about architecture. This means that if I were talking badly about your family or your friends, you would probably complain. This is even worse. This is about architecture, and you're probably going to complain even more. This is not the way to do things. Feel free to tweet anything, any comments, any opinions that you have to my Twitter account. Mention me, and we will have. Then let's go with the questions, and let me try to publish the polls so we can have these polls answered by you immediately. Okay, so this will be the first one, and I hope that you have it now in the chat. What is it? Ready. So do you write iOS apps? And if the answer is yes, I hope that you get the answers for the next questions. Even if you are not doing iOS apps, feel free to answer the next ones, okay? So the next one is whether you use MVVM or not. And if you do, then please answer this question now. And by MVVM, I mean Model View Model. The next one is whether you use Swift UI for your applications or you are still working with the old UI kit. And let me try to check the results on the first one. Okay, so a majority of people is doing iOS. MVVM, we have more mixed results. And regarding Swift UI, we are getting most of you in Swift UI. Okay, let me ask you a next question, and this would apply to anybody if you are not doing SwiftUI or iOS, still applies to you, whether you isolate, you use some abstraction to deal with your persistence. And that is another thing that I would like to know, because we will talk about that in the use case factory and so on. And finally, my question would be, if you are using anything more sophisticated for your architecture than the regular MVVM or MVP or MVC, okay? So those were the questions that I have for you. Let me share with you that the most people is doing is not using MVVM. Most people is not doing iOS, and most people is isolating their persistence, and also there is half and half results regarding the more sophisticated version of the architecture. So I hope that you like what we're going to talk about now. Let's talk about what architecture can be, and I hope that you agree with me that this is not about selling apps. I have never seen a customer buying an app because of the way it is implemented, whether it is using some design patterns or some others, or none at all. And it's not also a way to tell your colleagues, hey, this is the way you should do things because I'm smarter than you, or to show off in front of your community. This is not architecture. Architecture is similar, I would say, to martial art. You are trying to learn some movements and to be efficient in the way you do things in order to repeat this success and to have some learned patterns that you use when you find a good environment to solve it with that pattern. So what we're going to talk about here basically is mostly patterns, ways of doing things generically that are not a library. This is not a library. This is a way of implementing things that you can use in your own applications. From now on, this is going to be a high density talk, because I want to cover 3 topics and we only have 40 minutes and we have already skipped 5. So don't blink. This is going to be fast and painless, and we're going to get into the real thing very soon now. So let me start by being disciplined, which is one of the attitudes that you can have in martial arts, and that is regarding how you implement your views. And before talking about how to implement it, let me define what presentation logic is. And presentation logic is what you have in applications very well known as OmniFocus. I don't know if you use that one, but if you do, you probably will be aware that as you see in the screen, there is a date that is shown in 2 places, I mean 2 dates. And for each task, the date is presented in a different color depending on whether the date is due, which is red, or it is going to be due very soon. And it would be great if it is not due or due very soon. So that provides additional information to the user, and that is why this logic is not affecting the domain. It's additional information that the user can use to its own benefit. And that's something that we want to promote. That's something that we want to have in our applications. Same thing happens for a bank application. If you're doing transactions, the money you get in is usually green, because we associate typically green to positive things and red to bad things. So every time you give money to somebody else or you get charged, that is red. Even in the Apple stock apps that you find in your mobile phone, you will see several things that can be used as a presentation logic. So for example, for the weather application, you have this bar that shows you information of the gradient, I mean the range of temperatures that you're going to have that day, and is for Singapore at the time that I recorded this screen, because these are centigrades. These are warm temperatures, and Kusamo, which is in Finland, those are cold temperatures. So you have a gradient of colors that show you how much the temperature is changing and in which range it's moving on. So let's go back to MVVM, and if you're using it, let me very briefly recap how to implement it. You have a view, and the view has to be dumb. And dumb doesn't mean bad. It means that it has no intelligence. There is no logic in the view. Then every event that you have in the view will be passed on to the view model to provide meaning to that event. So when a user pushes a button, it will be sent to the view model, and the view model will decide what to do with that push of a button, with that press. The view model will have a model for the view, a model that describes what has to be shown in the view. And that means that it will have a text for each of the labels that have to be changed, or even properties that describe the color or where something is enabled or disabled. And it will notify of changes to the view. So it will notify the view. That is why we have another line there saying, hey, something has changed, so update yourself. There's no order that is given to the view. That's why the view is so dumb, okay? The view model interacts with the model and tells it to do things. For example, add this piece of data to the model because the user pressed on that button. And the model will also notify of changes to the view model in case it has to do something else. That's how model view model works. And the important fact here is that we want our views to be as dumb as possible. I know that it sounds strange because you usually don't want things to be dumb, but you do want to have views that are dumb. And I will explain why in a moment. So this will be an example of a view. It's very, very simplified. If you're not familiar with Swift UI, let me tell you that this describes a view stack would be like a vertical stack of views. And the view model will have a number for the quantity. And if the quantity is bigger than 0, we're going to format that number into the proper currency. And we're going to use the foreground color, the color for the letters, which is going to be green, for a number bigger than 0. And if the number is smaller than 0, if it's negative, if it is less than 0, then you will have the same format applied twice here. So that should give you a hint. And you will use the red color for the foreground. Well, as you can see here, this is something that is putting logic in the view. So if you try to test the view, you will be testing whether the proper format is there or not. Not a good idea because views are harder to test than view models. And also, if you have the same logic applied in several ways, it will be hard to apply those because you have to basically copy and paste the same piece of code and use it elsewhere, okay? So in my opinion, it would be much better to do this other way. Doing it this way, so you have just a single text view, not two, but a single one that is shown that contains the proper content, and the property that is offered by the view model is the text, which is already formatted. So when you do unit testing on your view model, it's going to be easier because you can check whether the format is the proper one, instead of taking a picture and verifying that the view has the proper amount there. And then you can have the transition color, which is going to be a view modifier, and we will use a view extension in order to apply this to all of the views. So it gets a color code from the view model saying whether you want a positive color or a negative color, and then it will transform that into a color in the UI. And you want to have these two pieces because you want the UI to be independent from the view model. You don't want to have any dependency on the way, the view model, you want it to be independent of the view. You don't want any dependency on UI color in the view model. Okay, so no logic in the view model. I hope that's clear. And if we do that, we have view dumb, the proper one, with presentation logic. So we will move the presentation logic elsewhere. It can be a class, it can be a function, it can be a struct, and you can do that. And that will give you a consistent behavior because every time you apply this formatting elsewhere, which will be applied in the view model, you can share it. If you have two views that do the same, you can share that formatter. And it is easier to maintain and evolve because it's written once. And it is easier to do the testing, as I explained before. Now let's go with making simple movements. And probably you have seen karate people doing katas, and they try to practice movements in a way that is repeatable, that they do this perfectly, and they have this palette of movements that they can use when they engage in combat. So we're going to do basically the same here. We're going to work with the domain logic. And Uh, when I talk to front-end developers, be it web developers or iOS or Android developers, mobile developers, sometimes they complain that they don't have much logic going on in their applications. And it might be the case. Some applications only talk to the persistence and bring data from back and forth from the server. But if it is not the case, then you should consider this option in order to implement your domain logic. So that is not meant for applications that only do data painting, okay? But if you have applications, and I have written here 3 examples, like if you're doing any audio, pictures, or movie edition, or if you're using some random password generation for a password manager, or when you calculate what is going to be the next task that the application is going to propose you to do based on some logic that is around the task or where you are or whatever, that is mostly going to take place in your front end and not in your back end. So sometimes it's not even that kind of logic. Sometimes that you want to do some operations that are attached to this. So for example, you want to keep the track of what things have happened, login, or you want to keep some statistics or whatever. That could also be included in the use case, so you don't have to repeat it and repeat it everywhere. Okay, so how do we do it? Well, generically, you can have a view model that is going to be the model for the view, as we mentioned before, and this view model is going to do the operation. So you tap on a button, let's say that this is a password manager, and you have a view that allows you to generate a new password, something that is going to be random for your new login. So you have this function that is called generate password, and it has some parameters like the number of characters that you want to be symbols, the number of characters that you want to be capital, the number of characters that you want to be numbers, and so on, and how you want to organize them. And this is going to generate a password for you. So the way we would use it from a view model is we get this password generated using this function, which is the domain logic, and then we will update the properties so that the view knows that something has changed and it will update that content on the screen. Okay, not terrible, but not the best way of doing things. You have unnecessary repetition if you are using this same password generation in more than 2 windows for any reason. You're probably going to have this code repeated more than once, and you want the code to be coherent. So you want to, if you do a change in one place, you want it to apply to any other place where you're using password generation. And again, testing the view model gets harder because now you want to do the unit test and the domain logic is there, it's not injected. So you cannot know which part is broken. You're not doing unit tests, you are doing a small integration test. So you're integrating 2 pieces, the domain and the view model, and checking the results of the behavior of these 2 pieces together, okay? So how can we do this better? Well, the first thing would be to put this in a class. We are going to put each of the domain use cases in a different class. So in this case, we have created a class for a password use case, a generate password use case, and we will have a function that gets the parameter and returns the result, the string that has the suggested password. Well, not terrible again, but that is not the solution for everything, because every use case that we have is going to have a creation in place. I mean, like, we are going to create the use case there because sometimes we don't know what the input is going to be. So because we need to do that, mostly we're going to pass the use case there. Okay, we can use the parameters there, but not the best option. The input and the output for the use case, I hope that you agree with me that each use case may have different inputs and different outputs, and we don't know which ones they are going to be. I mean, like, they might be use case input might return a string, like is in the use case in the password generation use case, or let's say that you want to validate if a password is fragile or not. Then you have a use case for that. You pass a string, not parameters, and you return a true or false, saying it is fragile or not. Oh, that is completely different. Again, testing the view model is harder because you have to create the instance mostly there. So not solving every problem here. Let's use something better. Let's implement each use case in a class, but let's use the common design pattern. And the common design pattern is a pattern that is very simple to apply. You define things that can be executed. And that means that you use a protocol. This will be an abstraction in the language that you use. So if you're using Kotlin, it would be an interface, or Java. And this protocol or this interface or this abstraction, whatever it is that you use, a trait for Rust, you want it to have just a single method that takes no parameters in and returns no results out. Okay, so it's just an execution without parameters, without output. And what you will be doing is you create this new class that implements this protocol, and you will take the parameters and the things that have to be done with the parameters as arguments for the constructor, in this case, the initializer, because we're talking about Swift. So you will get whatever parameters you need for the creating the instance of the use case, and then you will pass a closure, which takes a string, which will be the result of the password that you have generated, and you can put in that place whatever you want to do with that. The way you would use that is in a use case factory, and the factory will have one method for each of the use cases that you want to return, and each method will get both the inputs and the outputs that are not shared among all the other use cases. So you will be returning from this method a use case, something that can be executed, and you don't have to worry about how to use that. Let me show you how to use that. We have the same view model that we had before, and we get the use case factory injected in the constructor, so we don't have to worry about that anymore, because that can be modified for testing. We can make a mock in order to deal with that. And when we are going to deal with the function that is called when the button is pressed, we create a use case at that exact moment with the proper parameters, and we pass at the end of that a closure. The curly braces that we have there will have the content there, the code required to update the property in the view model. The only thing that we have to do after that is to execute that use case. That's it. Nothing else, nothing more. Okay? So that's how you use a use case factory. And probably you will be saying, oh, but I want async await. And what you told me is not for async await. And that's totally true. My fault. So let me go with async await. In case you're not familiar with async await, or at least the way it is implemented in Swift, well, the way you implement things in Swift is by defining a function, same thing that we were doing before. And this has a typo. It has missing the return time, which is a string, but the function is exactly the same as before, but it has the async and throws attribute. The async means that it has to be executed in some task content, and or some other content for concurrency, and the throws means that it may return an error. And you will return that, but the way you invoke it, as you can see in the last line of the code, is as a regular non-asynchronous function. So it behaves asynchronously, but the asynchronicity happens magically in behind the curtains. So now that we have this behavior, we are worried about our use case factory because, hey, we cannot use the closures that we were injecting in the constructor of the use cases. And also, each of these use cases that we will be implementing as async functions are going to be somehow broken because we cannot generalize. Each one is going to have an input and an output, as we had before. And there's no much information if we create the use case factory, as we were doing before, about whether we should execute that in a task or not. So how do we solve that? Well, let me introduce you to enums with associated types, which you will probably know. And we will be using one for the inputs, one for the outputs. For each of the use cases that you're going to use, you will have a case in the use case input enumeration, which will have associated types, associated values for each of the parameters that you have to put into this use case. And then you will have another case in the use case output enumeration, which will have associated values for each of the results that you are going to return from the function, from the use case. It may be nothing for each one of them, but it may be something or several values, okay? So how do you use that? Well, now we're going to define the new H command pattern with asynchronous behavior. So instead of defining this function that is executed, that takes no inputs and returns no outputs, we're going to take an input, which will be an instance of this enumeration, which is the use case input, and then it will be asynchronous and it may throw, and you have the use case output. Wow, that's amazing. I'm like, we have everything we wanted there. Now we only have to implement that. And what we're going to do is to implement our use case in a way that we inject other stuff if we need it in the initializer, but everything else is using when you execute it, you just have to put it into the enum use case, and you just have to get the result back as the case from the use case output enumeration and parse it from there. So you have to be aware that because this is a sync throws method, it has to be invoked in the proper context, and it may throw some error back to you, so you have to invoke it within a try-catch, do try-catch environment. Okay, that's it. That's all we wanted to have an async use case factory, and it can be implemented, and it provides you with a lot of tools, a lot of resources to have all of your use cases implemented everywhere, so you don't have to worry about dependency injection of each of the use cases. You just have to inject the use case factory and consume on demand when you need it. It is easier to use, it is easier to test because you can replace the use case factory and return a damn use case, and you can have this asynchronous behavior built in and with the help of the compiler that will tell you, hey, this is a function that has to be run in an async context. Okay, let's go with the latest one. We're going to be practical. And yes, like in martial arts here, you want to do things that are not very fancy. Forget about martial arts movies. I mean, like you want to be efficient in your movements and want to be able to move from one position to the next, keeping stability. So what we're going to talk about here is navigation. And in navigation, probably if you are familiar with the clean architecture, you have realized that when you have this diagram that Uncle Bob made famous, you have all the layers. The entity is like the center for your application. The interactor is the name that he used for the use cases. Then you have the presenter, which in our case is the view model. And then we have views and also any other kind of additional devices, information, network, persistence that you're dealing with. So this is like the hardware dependent layer. But there's no real thing about navigation here. There's nothing saying, hey, you should be worried about navigation. So what do we do here? Where do we put navigation? Well, navigation, the way we wanted to have navigation in our applications is by these events, like clicking on a cell takes you to a different window. So clicking on a cell is the event. The semantics, which is taking you to another window, these are the semantics. And as we mentioned before, when we were talking about model, view model, they have to be separated because that is easier. I mean, testing the semantics in the view model is much easier than doing it in the view. We want to be able to do this fancy dependency injection that I was mentioning when talking about initially the presentation logic and later on and more emphatically about the use case factories. And we want this solution to be SwiftUI compatible. I mean, at the end of the day, we were talking about SwiftUI. So we would like to have this in a SwiftUI way of doing things. And finally, we would like to have some superpowers. We would like to have things that we can do that are harder to do if you do it in any other way, which is, for example, I want to be able to redirect things or change the flow of navigation of my application very easily. I would like to be able to do things like, hey, if I'm doing some feature flag in order to do development, then you can go and navigate to this window when the flag is enabled, or navigate to this other when the flag is disabled. And that would be happening thanks to the connectors. So what we are going to do is to have these three kits here. The first one is, again, the view. We talk about that when we were talking about view models, model view models. And as we mentioned before, is the pretty thing in our application, but it has to be passive. I mean, like, it doesn't have to be intelligent. It should be as dumb as possible. It will receive the events that the user does by interacting, or even the system events, and we will pass them onto the view model. And it knows how to navigate. I mean, like, in the case of Swift UI, it has the navigation link that allows you to go to another window, or even it has the dot sheet that allows you to present something modally. So all this stuff is part of the view, but we don't want the view to take decisions. We just want the view to have the infrastructure ready to do the navigation. Then we have the view model. That is the one that provides the view, the meaning to these user events, and is the model, the things that have to be represented in the view. And that is the part that I was mentioning before. It will also be the one responsible for notifying the view, hey, something has changed, you have to be aware of that. And it knows, because it provides the semantics to these events, it knows when to navigate and where to navigate. That are the two things that we will decide in the view model, semantics. Finally, we have the connector. This piece is probably unknown to you. You may have heard some other names, but I don't know if they're referring exactly to the same construction. So this is my name. I call it connector. You can go with any other name. The idea is that you have some piece that takes care of the dependency injection and how to build the things. It is like the thing that knows how to assemble each of the views, and it takes you to the next connector. So when you create a connector, you will be having the information for the next connectors that you can navigate to. Let's talk about navigation in the way it happens in iOS, and then we will talk about how the connector gets implemented. This is an oversimplified case of navigation. So let's say that you have this in a navigation view. That's important because otherwise the navigation link will be disabled. And in this view that I have called one view, you have a navigation link, which is the one that knows how to do the navigation. And you have to put there in one of the closures that it has, in the first one, the the destination view that you want to navigate to when you use this link. And then in the label closure, the one that is in the last three lines of the body, you have this view that is going to be what is going to be shown on the screen. In this case, it's going to be a text. If you click on that text, you will be navigating to this destination view that in most cases, at least in my cases, it requires a destination view model with some additional parameters like the use case factory and so on. How do we decouple navigation? We use a navigation link, that's a requirement, but then we use the navigation link with the isActive property. And this is some state property that we're going to set it to true or false based on the navigation. We will have this navigation link in the view, but it will have no information. That is why I have the empty view here. But this is still using the destination view. Is hard-coded there. There is no dependency injection other than putting all the pieces there and making your view aware of all the dependencies that you have to create. And that is not something that we want. We would like to replace that piece there, this destination view model, by something that does this in an isolated way, in a decoupled way from the view. Okay, so how do we go about that? Well, we use a connector. And a connector, for each of the views that you will have a connector. And the connector will know how to assemble its view. And this is where you do the dependency injection. The connector is the only one that knows that in order to create the one view, it uses the one view model, which requires a use case factory and even a persistence factory, for example, or any other API gateway or anything that you have there. Or if you're using the Realm Kit, the Realm SDK, you have that there. And it will also have a function that will do the navigation. The navigation will use an enum destination. So all the destinations where one view can navigate to, and it will use a switch after the if let in order to choose this destination. So this switch is going to choose for each of the navigation, return the proper destination. So based on that, it will create the proper view. You can even do this lazy, which is the proper way of doing this, because every time you use that in a view, you have everything created, even the things that are inside of a navigation link. So as you can see here, you have the dependency injection in the assemble, and you have the navigation tool in the connector. So when you create initially the application struct, you will have the main connector, and you will use that inside of the application in order to create the first view. It will inject itself in the first view, and from there, it can be used to navigate to other destinations. And that's how you get the next view, the next assemble, that is the destination one connector that you see there. So when you have these connectors in place, you can navigate like this. Same structure as before, connector, navigate to view model, nav destination. Much easier. The view model decides the destination in an abstract way, and the connector knows how to implement this destination and navigate to it. Isn't it cool? Okay. So I hope you like it, because now we have the coupled navigation, we have easy dependency injection, and we have a destination that can be chosen, not only with the logic of the view model, but also we can do fancy things, as I was saying before, with A/B testing, or the example that I put with the feature. So I want to go very briefly through a recap of the things that I've done. I know that it has a lot of content, and feel free to ask me any questions afterwards. I just would like you to try these concepts that I mentioned. And there's a hackathon going on in MongoDB. I have created this build link for you. So 22 MongoDB MDB hackathon. And you can use it for getting access to the hackathon. Obviously, it's free, and it is not a one night or a weekend hackathon. It goes on for a few weeks. So you can use this real data, that is data about news in the world, about things that that are geolocated, and it has a tone indicator, depending on whether things are good or bad in this news. And they date back to, I believe it's 1979. So a whole big set of data that you can use in order to practice these concepts that I was mentioning there. You can create your own application, use the real data, and see how this works in your implementation. And finally, I will go with what we have implemented. So we have implemented, hopefully, a little bit more advanced architecture. This is clean architecture plus, or at least solving some of the issues that you have, basically clean architecture, if you don't deal with these issues. And formatters are the solution. The formatter is how you isolate this presentation and how you reuse the code that you have for that. The use case factories are the things that we are implementing, where we are implementing the domain logic, and they can be asynchronous, as I mentioned before, and they behave in a way that it can be used in every view controller. You just have to implement the use case factory. And if you even implement persistence factory, that I'm sorry, but I didn't have the time to share with you today, it would be awesome, because you just have to do an injection and it will take care of all the persistence connection and all the data there. Finally, I have shared with you how to do navigation in a more decoupled and repeatable way, and I would say even more powerful way, using connectors. So I know that I shared with you at the beginning. Now that you have seen what I wanted to share with you regarding architecture, now you're more than welcome to send me a tweet and say, hey, I do not agree with anything you said there. Everything is wrong. This is how you should do things. I would love to have that discussion. Okay. So feel free to send me a tweet, and we can continue this conversation later on. Thank you very, very much for coming to this talk. I hope it has been clear, but obviously I have some time for you for Q&A. And Karen, if you can help me with this, the Q&A, I will be more than glad to answer questions.
Sure. Thank you very much, Jorge. I hope everyone enjoyed this session and learned something new. I have a few questions of my own, if I can ask. And please feel free to ask him question under the chat, the Q&A chat. As a mobile developer, do you have iPhone or an Android device?
I do have both. To be completely honest, I mostly use my iPhone as my personal device, but I write code for both, and I love writing code for both.
I see. So you haven't picked a side.
Regarding code, I think it's a fight that is going on, and I believe it's good for developers because developers can benefit from two companies that put a lot of resources into do a better development of these platforms. And I think that it is pretty clear that they are learning from each other. So one year Google releases something for Android, and the next year it appears in iOS, and the other way around. One year Apple releases something for iOS, and the next year we have some alternative for Android. So yeah, I love that there's this competition exists.
Yeah. And another question is, where do you see the mobile industry going to? If you have any thoughts on it.
If I were good at that, I would probably be rich instead of a developer. But I think that more and more, and we see this in the older people, like my mom or people their age, that it wasn't the case before that people were able to use technology and connect to the internet. But we will be soon, air quotes, older, and we will be using this technology. So it will apply to more people, and it will be used for more things that we see now. Some people have completely replaced having a PC at home by having some mobile device. It can be just a mobile or even a tablet. And even under this pandemic that we have had in the past years, having the ability to use some technical resources like that has been a very good resource for keeping people in schools, for keeping people working, and all these things. So we're more and more dependent on that. So I think it's and if you're in LinkedIn and you have some mobile developer profile, you know that you have a lot of chances to work in this field. So
thank you. And any advice for a beginner in the field of mobile development? How to
try
get
and fail.
started?
I'm like, yeah, sure. I'm like, I think that there are things that you could do. There are plenty of projects that you can get involved in. You just learn the basics. There are plenty of resources. By the way, I was planning to create some videos about architecture, starting from things that are a little bit more basic than the shares that I did here, and creating these videos to talk about architecture for both platforms. If you're interested in those, send me a tweet, and I will try to allocate the time to create these resources. But there are excellent resources. Paul Hudson creates good courses for introduction to iOS. There are excellent resources for Android, like my friend Antonio Leiva has a good book about writing architecture and coding, and he also delivers some trainings. So yeah, excellent people that you can use in order to learn from them and to get the basics. And from there, you can try to use these learnings and apply them to real applications. I will start with some open source, but then try to move into the market as soon as possible because the market is hot.
I see. So thank you very much, Jorge, for your experience and sharing your knowledge. I hope everyone enjoyed the session, and see you on the next session. Have a great day. Bye, everyone.
Thank you. Bye.